In this video, we're going to talk about how we backup and recover Microsoft SQL Server databases using Google Cloud Backup and DR. So there are a few things we need to do to set the scene. We need to install the Backup and DR service, which will give us our management console running as a service, and deploy a backup and recovery appliance into one of our projects, which is running as a compute engine instance. And this is going to do the work of performing the backups. The backup and recovery appliance will have a snapshot pool based on persistent disk, and we should add an on-vault pool to it, which is running in Google Cloud Storage. What we then do is we deploy the backup and DR agent into any of our Windows servers. This could be compute engine instances, compute engine VMs, or it could be VMware VMs. And obviously we're doing this because these Windows servers are running a SQL Server database, or maybe even just a Windows file system that we want to back up. So there is a two-step process here. We need to discover the applications, which we do using our onboarding wizard, and we then apply a backup plan to them. And we can apply that to a SQL instance or a SQL database, or what we could do is create a consistency group, and that consists of databases or instance on the same host that we want to back up as a consistent group. And we can also just apply backup plans to Windows file systems like our C drive and our D drive. The backup process is a six-step process. We first connect with the application, which means the backup and recovery appliance talks to the backup and DR agent on the Windows server. That's done on port 5106. It then confirms that everything is ready to go, and then brings across over iSCSI in step 2 a backup disk. So this is a virtual disk presented out of the snapshot pool that the Windows server views as a real disk. And what it then does is, again, in coordination with the backup and DR agent, is we get Microsoft SQL Server to use its VSS provider to create a VSS snapshot of the source drives. And then we make a copy of that VSS snapshot onto our backup disk. The first time we do that is a full copy. The second time is incremental. We merge just the change blocks, which we track using our change block tracking driver. After every backup, we create an internal snapshot of this backup disk, which is effectively our internal backup stored in the snapshot pool. And then optionally, we can copy the change blocks, which, and again, in the first case would be all the blocks, and then in subsequent backups, change blocks, into the on-vault pool for effectively what is our offsite storage into a second location. And you can have multiple on-vault pools, and you can have multiple policies determining how long we retain the backups in both the on-vault pool and the snapshot pool. Optionally, we can also back up logs. Log backup jobs are run separately to the database backup jobs, which makes sense. You can run the log backup jobs as often as every 15 minutes, but the process is exactly the same. We connect with the application, we share a SCSI disk, we copy the logs onto that disk, and then we use internal snapshots to maintain copies of it. And again, we can optionally push those log backups up to on-vault to store them externally to the backup and recovery appliance. From a restoration perspective, we have a lot of choices, and they're all really good ones. We can do a mount where we simply mount a copy of the virtual disk, which the backup is on, to any server, both the source server or any other target server, and we can then start that database. The other option is we can do a traditional restore. So a traditional restore is we connect with the source host, present the backup disk to it, and then copy the backup over the top of our presumably corrupted or unworkable database. We can also do a thing called a clone, and a clone is effectively a bit like a restore, but it's to any host. So we can clone the database to any host that we want to, in addition to restoring the source host. In terms of setup steps, we need to activate the backup DR service, which I just talked about. We then need to create a Google Cloud Storage bucket for on-vault. We need to validate our ingress and potentially our egress firewall rules. What we're thinking about particularly is port 3260 for ingress into the backup and recovery appliance, and port 5106 for ingress into the host servers that are running the agent. And obviously, for every host that we want to do an agent-based backup, we need to download and install the Windows agent, taking care to ensure that we activate CBT and copy a thing called the shared secret. And we're going to talk about all of this in forthcoming videos. What we then do is we switch across to the backup and DR service itself, add the cloud storage bucket as an on-vault pool. We create our backup plans. We add our Windows host using that shared secret, onboard our applications and apply our backup plans to them, and then begin the process of recovering our applications when we need it. So what we're going to do in subsequent videos is talk you through all of these steps.